Hello, welcome to video 4H. This time we're doing related rates problems that involve right triangles. I'm Mr. Miller and I hope you're doing fine. Here's our first problem. We have a basic right triangle here. It has two legs. One is 12 centimeters and one is simply labeled as B, and the hypotenuse is C. So it says in the figure on the right, B is increasing at a rate of 3 centimeters per second. So this side is getting longer. Find the following when B equals 9 centimeters. Well, first, the area of the triangle is changing. Okay, we got this. We start off with a formula for the area. Area equals, for a triangle, 1/2 the base times the height. So this would be 1/2 times 12, and B is the height of the triangle. So we get area equals 1/2 times 12 is 6. 6B. Now, this is a related rates problem. We're getting used to these. And we take the derivative of the equation with respect to time. So we get dA dt equals 6 times dB dt. I think this is the easiest one we've done so far. Well, B is changing rate at 3 centimeters per second, so that's 3. So we get dA dt equals 6 times 3, which is 18, and the units would be centimeters squared per second. Okay, so that wasn't so bad. Now we want to find the rate that C, the hypotenuse, is changing. So we need a formula that relates C and B, and that would be the Pythagorean theorem. Pythagorean theorem says that C squared equals A squared, which would be 12 squared, plus B squared. Or we get C squared equals 144 plus B squared. And now we take the derivative with respect to T, remembering that C and B are both functions of T, so we need the general power rule for both. So when we take the derivative of this, we get 2C dC dt. That's using the power rule. Equals, well, the derivative of 144 is 0. Plus, we need the derivative of B squared. That'd be 2B dB dt. And we see we can cancel the 2, so we forget about those. Now, we plug in things we know. We know dC dt. No, we don't. We want to find that. We know B is 9. dB dt is 3. We got to find C. So now we plug in things we know. We want dC dt. We know B. We know dB dt. We don't know C. We got to take a second to find that. So when B is 9, we can use the Pythagorean theorem here. 12 squared plus 9 squared equals C squared. So 144 plus 81, that would be 225 equals C squared, or C equals square root of that, which is 15. Okay, now we can substitute into this equation. C is 15. We want to find the C dt, so we don't know that, equals B is 9, and dB dt is 3. So we get dC dt equals 9 times 3 over 15, which is 9 over 5, 9/5. Okay, and 9/5 would be 2.2, I believe. And no, I'm lying. That would be 1.8. Sorry about that. And so 1.8, and that would be centimeters per second. So if B increases at 3 centimeters per second, we know that this length here is increasing by 1.8 centimeters per second. Okay, here's a similar problem. Brenda is walking east on Belmont. So we have a little map here. And so this is Brenda walking along the base of the triangle. So Brenda is right there. And Claire is walking north. Claire is up here. I'll give Claire some hair. There's Claire. There's Brenda. Okay. Let x equal Brenda's distance from the corner. So that here's x. And y equal Claire's distance from the corner. There's y. And it says Brenda is 15 feet from the corner. So this is 15. And walking at 3 feet per second. So she's going that way at 3 feet per second. And Claire is 20 feet from the corner. So this is 20. And she's walking at 5 feet per second that way. Okay. Now, find the rate the distance between them is changing. That's c. Okay, so we can use the Pythagorean theorem. X squared plus y squared equals c squared. Or c squared is x squared plus y squared. All three of these are functions of time. So let's take a derivative. 2c dc dt would equal 2x dx dt plus 2y dy dt. In fact, we can get rid of all the 2's. We can divide everything by 2. We have c dc dt, which is what we want to find, equals x dx dt plus y dy dt. Well, time to start plugging in things we know. First, we need c. Well, we got to use the Pythagorean theorem to find c. 15 squared plus 20 squared is c squared. And I think if you do that, you find that c is 25. So we got 25 dc dt equals x. That was Brenda's distance, 15, times how fast she's walking, 3, plus y, that's Claire. She's 20 feet away, times how fast she's walking, 5. And we just got to solve for dc dt. So we get 25 dc dt equals, well, that's 45 plus 100, which is 145. We get dc dt equals 145 over 25. And I think that's 29 over 5. Okay. And that would be in feet per second. So if Brenda's walking this way at 3 feet per second, and Claire this way at 5 feet per second, the distance between them is changing at 29/5 feet per second. Okay, we got this. Here's another classic problem involving the right triangle and the Pythagorean theorem. It's the sliding ladder problem. So we have a 25-foot ladder. That's the hypotenuse, and it's always 25 feet. It's leaning against the wall. Suppose x equals 6 feet. So the bottom is 6 feet from the wall. And dx dt equals 2 feet per second. So it's slipping this way, 2 feet per second. We want to know how fast is the top of the ladder moving down the wall. Okay, so we need a relationship between x and y. We know dx dt. We want to know dy dt. So we got to use the Pythagorean theorem. X squared plus y squared equals 25 squared. All right, that's the Pythagorean theorem. If we take derivatives, 2x dx dt plus 2y dy dt equals, the derivative of 25 squared is 0 since it's a constant. In fact, we can kill the 2's. All right, now let's start plugging in things we know. We know x is 6. The x dt is 2. X is increasing. Plus y. We don't know y. We can figure that out from the Pythagorean theorem though. Y squared plus 6 squared is 25 squared. So y squared is, well, that's 625 minus 36 So 625 minus 36 is 589. So y is the square root of 589, which is probably some ugly number. So here we go. We need it right there. That's what y is. Square root of 589. Then dy dt equals 0. So we can solve for dy dt. This is 12, so we can move that to the other side. And so that'd be minus 12 over here. And we're going to divide by square root of 589. Okay, and that would be feet per second. Now, I'm going to leave it like this instead of finding the decimal. But I want to point out it's negative, and it should be negative because the height here is decreasing. So that means its derivative should be negative, which it is. Okay, now find the rate of change for the area of the triangle formed by the ladder. Okay, well, area is 1/2 the base, which is x, times the height, which is y. So dA dt would equal 1/2, well, we need the product rule here. It'd be the derivative of x times y plus x times the derivative of y. All right, now I think we have all four of these quantities. Dx dt is 2. Y we figured out was a nice square root of 589 plus x is 6, and dy dt is our answer from above. Now I really wish I had found it, but it's times negative 12 over square root of 589. Okay, what a mess. But we could find the decimal for that. I'm not going to, but if we found the decimal, that's the rate the area is changing. Okay, here's this problem. So we have a plane flying east at 500 feet per second at a constant altitude of 4,000 feet. So it's going along this horizontal line. So this distance doesn't change, the 4,000 feet. The plane is being tracked by a searchlight on the ground. There's the searchlight. And the plane is currently a horizontal distance of 2,000 feet. That means the distance from the searchlight to the spot directly under the plane is 2,000. Find dc dt, the distance between, or the rate of change of the distance between the searchlight and the plane. Well, okay, we need the Pythagorean theorem again. So, this time x squared plus 4,000 squared equals c squared. Okay, so we're going to take the derivative. 2x dx dt. Well, derivative of 4,000 squared is 0 equals 2c dc dt. And kill the 2's. So we have x, which is 2,000, times dx dt. Actually, that was given to us. The plane is flying at 500 feet per second this way. That's how fast its horizontal distance is changing. So that's 500 equals c. Uh-oh, I gotta figure out c. Well, okay, from the Pythagorean theorem, c squared is 2,000 squared plus 4,000 squared. Whoops. So c is the square root of 2,000 squared plus 4,000 squared, which equals 4,472.1 feet. So this would be 4,472.1 dc dt. Okay, so if we divide by this, we have dc dt. So dc dt equals 2,000 times 500 divided by 4,472.1. And I get approximately 223.6. And that'd be feet per second. Okay, so if the plane is moving this way at 500 feet per second, this distance here from the spotlight to the plane is changing at 223.6 feet per second. All right, well, we've made it to our last problem. So this is a classic shadow problem. This is a 6 foot tall person is walking away from a lamppost that's 15 feet tall, and their speed is 4 feet per second. Okay, so in this diagram, I don't know if you can see this, but y is the distance from the lamppost to the person, and x is the length of the shadow. Okay, so we want to know the length of the shadow is changing when they're 12 feet from the lamp. So y is 12, and dy dt is their speed they're walking away, which is 4 feet per second. And we want to know what dx dt is. Okay, let's see if we can do this. So we see we have two similar triangles here. We have the triangle formed by the 6 foot person. That's a small triangle right there. We have this big triangle formed by the lamppost. They're similar. So the ratio of 6 to 15. That's this side of the left side of the small triangle to the left side of the big triangle. That ratio is the same as x, the bottom of the small triangle, to the quantity x plus y, which is the total length of the bottom of the big triangle. Okay, so I'm going to cross multiply. 6 times x plus y would be 6x plus 6y equals 15x. If I subtract 6x from both sides, I get 6y equals 15 minus 6 is 9x. Or we get that, well, I want to solve for x. So I get x is 6/9 y, or x is 2/3 y. So dx dt would be 2/3 dy dt. Okay, so we had to do, it was a little complicated geometry here to find a relationship between x and y, but once we have that, the derivatives are easy. So now, if dy dt is 4, we get dx dt is 2/3 times 4, which is 8/3. So 8/3 would be 2 2/3, or about 2.67, and that would be feet per second. All right, find the rate the tip of the shadow is moving. Well, the tip of the shadow, the distance from that to the lamppost, is y plus x. So the total distance, I'm going to call it t, is x plus y. So the derivative of that total distance would be dx dt plus dy dt. And we know both of those. Dx dt, we figured out was 8/3. And dy dt was given as 4. So 4 is 12/3. This would equal 20/3, which is the same as 6 2/3 feet per second. That's how fast the tip of the shadow is changing. Wow, I know this is a lot. We'll be going over this in class also, but these are kind of really classic and fun calc problems. They involve a lot of wonderful math. All right, I have two problems for you. First is like our first example, a little bit. We have a right triangle, and sides A, B, and C are given. A is 6, B is 8, and C is 10. But they're changing. Suppose side A is changing at the rate of 2 centimeters per second, and B is changing at the rate of 3 centimeters per second. Well, use the Pythagorean theorem and take derivatives to find how fast C is changing. Okay. Then we have a classic ladder problem here. A 10-foot ladder is leaning against the wall. The bottom of the ladder is 6 feet from the wall and is sliding away from the wall at a speed of 2 feet per minute. Okay. Now, find the rate at which the top of the ladder is sliding down the wall. Just to make the problem a little bit easier, when x is 6, you could use the Pythagorean theorem to find that y is 8. So to help you out a little bit, you'll need x and y. You also need their derivatives. Okay, good luck in all this.